In this video lecture, we're going to be talking about custom painting in Java. Custom painting involves drawing the application-dependent aspects of an application, such as the game board and game pieces in a game, or the circuits and gates that you might create in a computer-aided design application. It does not cover drawing the so-called input graphics like text boxes, menus, radio buttons, since those are already provided for you in a widget library. The notes for this class can be found basically with the custom painting tutorial that Oracle provides, and we're essentially going to be working through this tutorial for the lecture. And what we're going to be doing is going through a series of demos where we slowly build up more complicated programs, and with each program we'll introduce a few more aspects to custom painting. And finally at the end we will go through a summary of the techniques you need to use for custom painting. So we'll start right in with a first demo, and you'll see that it's very basic what we're going to do to begin with. First of all, we are going to create a method called create and show GUI. And this is kind of a pattern in Java that's used for creating GUIs, and it's a common name to use. You can see that when we run our main that we actually call create and show GUI, and that as always we're doing it by invoking this invoke later method from the swing utility so that it's put on the event thread. And just so that you can see the difference between writing to the console and later creating graphics in a window, we've put actually a print line statement in here that's going to print a line to the console. And then the bare bones that you need for creating custom graphics is you start with a window, which is a JFrame, and then you set some of its properties. So this default close operation tells Java what to do when you hit that close button in the window. By default it makes the window disappear, but the application keeps running. And because we're creating a single window application, we actually would like for the application to close and exit. And the JFrame defines several constants that define what can happen when you hit the close button. We're choosing exit on close. Then set size is setting the size of our window to be 250 by 250 bytes. And finally we're setting our visibility to be true. That's all we're doing with this demo. So as you're going to see when I run it is that we are going to simply get a window. And notice I'm having to use the class path variable because this is in something called the painting package. So I have to tell Java where to find it. And you can see it's created an empty window up here, and down here it actually created a string right here that says created GUI on Eastern Daylight Time and true. You can ignore the error message. This is something that is specific to OSS Mavericks 9 and unfortunately should not be there. It won't typically appear on Windows machines. Okay, so that's just getting a window, but that's not too interesting. Typically we want to draw something to that window. Well, you may remember from previous lectures that you don't draw directly to a JFrame. You may remember that every JFrame has something called a content pane, and that content pane is a JPanel. Well, we don't draw to this JPanel either, and the reason is we can't override something called its paint component method, which we'll get to in a moment. So we're typically going to create our own JPanel and either make it add it to the content pane, or sometimes we'll actually create a JPanel and replace the content pane. Either one works. And also it depends whether you're creating a widget or a canvas, but typically if you're creating a widget, you would use a J component. If you're creating a canvas-like object, say as a drawing editor, typically you create a J panel. And it's either one really works, so I wouldn't get too hung up on which one to use. Now there's two important methods that we're going to have to override in order to get some useful graphics. The first is the paint component method provided by a JPanel, and that's where we're going to do our drawing commands. The second method we're going to have to override is something called get preferred size, and you should remember from the layout manager video that get preferred size tells Java what our natural size should be. So let's take a look at our next example. And you'll see now that we're creating a JPanel called MyPanel, an extending JPanel. And you'll see that we have created a get preferred size method that's overriding the default one and returning a dimension object. That's how we specify our size. It says we'd like to be 250 by 200. And you'll also see we have over in the paint components method, and it takes an object called a graphics object. Now a graphics object is the object that allows us to draw objects, it allows us to fill objects, allows us to set colors, set line styles. It's the object we'll be using in this class for drawing. There is another class called Graphics 2D. So we have a graphics class, and then the Swing, when it came in, introduced something called Graphics 2D that has a lot more capabilities, and which I'm saying is beyond the scope of this class. So this gives us the ability to, what we say, stroke objects. So graphics can stroke an object, which means draw an object with no fill, just its border. And then we can fill objects with a color. So that would actually be filling it in. Gives us a way to set the color and to set a line style. And it's pretty basic in the graphics objects, but it gives us the basic capability for drawing things. So in our little example, you can see that we are using the graphics object to draw a string, and it's called "This is my custom panel," and we're telling it to put it at the XY coordinates 10, 20. We'll talk about this super.paint component call in a little bit, so don't worry about it for the moment. And then right here, setting the border, this is just setting a nice little border around our JPanel. Borders help us to distinguish different objects from one another by putting some kind of border around them. And you will see up here in my Create and Show, I have changed just slightly my procedure for making the J-frame visible. So now I am adding an instance of my panel to F, and as you can see, you can add it directly to the J-frame. What this does is actually adds it to the content pane. It doesn't add it to the J-frame, it adds it to the content pane, and by default it's put in the center of a border layout. Then we call pack. So instead of using set size like we did just a moment ago for the size of the frame, now we're using pack, which is the preferred way of setting the size of a window, since we basically want the window to be just big enough to accommodate the natural size of its components. And finally, we set the visibility to true. So if we run this one, you see that we get a thing with "This is my custom panel." And there's something very important here. Oftentimes beginners will forget to override the get preferred size method. So I am just going to comment this out for a moment to show you what happens if you should forget to do the get preferred size method. And I will compile it, again using the class path variable because it's part of a package. And I'll run it. And you'll notice that I got a super tiny window here. That's because, see down here, a super tiny window. The reason we got this super tiny window is that the natural size of a JPanel, the default, is something really tiny. So you need to remember to override the get preferred size method or else you'll end up with this really tiny window. Also note if I hit this red button, which on the Mac is the close button, that the application exits. Okay, so that kind of gave us just some simple drawing, and we're going to next want to do some event handling because typically we need to interact with our window in some way, and we're going to have some objects that want to interact. Now, text strings are a bit tricky because their width and height depends on the font they're rendered in, and it can be somewhat tricky to get a hold of that font information, so we're not going to deal with that in this course. I'll deal with it in a GUI class. Instead, we'll concentrate on drawing a rectangle and moving it around the screen. So with event handling, you've already learned that Java for event handling uses, so let's just put up here first of all event handling. And you may remember that it uses something called a listener model. So there are entities that generate events. JFrames are one such thing, or actually, I should say JPanels are one such entity. They generate events, and you can register with a JPanel to listen to the various events. And you may remember that events, if you have an event called XXX event, then you have something called a XXX listener, which is an interface that defines a number of different types of methods to respond to that XXX event, and that there is also an XXX adapter, which is going to be a class which implements the listener and that provides empty method bodies for each of the event handling functions. And that way, if there's, say, 5 event handling functions in the listener and you only want 1 or 2 of them, you'd use an adapter and only have to override 1 or 2 methods. Whereas if you implemented the listener, not only would you have to provide the 1 or 2 methods that you are interested in, but provide empty method bodies for the remaining 4 or 5. So we are going to have to what we're going to do is draw a rectangle, and then we're going to have it respond to a mouse event, and we're going to be able to move the rectangle around the screen. So I'm first going to demo that activity for you. So you can see I've drawn a red rectangle and I can move it around the screen. So this is the behavior that I want to implement. So let's take a look at that code to create it. So this is just working on the code we previously had, and now again we just have a JPanel, and I changed the name here only because my panel was conflicting with the my panel from the other demo. So this is really the same JPanel as before. So now we're saying our square starts out at location 50, 50, those are what these 2 instance variables say, and it has a width and height of 20. So we are going to want to listen to or handle 2 different types of events. The first is going to be a mouse pressed event. So when I press down on the screen, I want the rectangle to jump to that mouse point, and then as I drag the mouse around the screen, I want to be notified and handle the mouse dragged event, as you can see right here, and again I'll be moving the rectangle around the screen. So as you can see, I am In this case, I have a mouse event, so I'm adding a mouse listener, and to create that mouse listener, you can see I'm creating a mouse adapter, because if you look at mouse listener, you'll see it has 5 methods, and the only one we care about is mouse pressed. So we're creating an anonymous inner class here, and all mouse methods take this mouse event, and from it we're extracting the x and y coordinates of the event and calling a method move square. So mouse motion, when you're moving the mouse around, is different from mouse clicks and mouse releases. So we have to add a second listener that listens for mouse dragged events, and that mouse dragged event is when you have the mouse down and are dragging it. And in this case, we also want to move the square, setting its x and y coordinates. And if we look at move square, you will see that it is checking to see if the x or y change. So it's possible that it did not change, that for whatever reason, the x and y coordinates passed in by the mouse are exactly the same as the existing coordinates, in which case we'd do nothing. Otherwise, you see that we update the square's x and y coordinates. You'll also see that before we update its coordinates, we call repaint, and after we update its coordinates, we call repaint. So what are we doing here? Repaint cues a paint event, and that paint event we'll call paint component. Remember, paint component contains the code that does the drawing. You should never, ever put your paint code in an event handler or in a callback procedure like move square. That is a hard and fast rule. You put your painting code either in paint component or functions called by paint component. In your event handlers, you simply update object state, like updating the model state, and then you let paint component later actually re-render the application's state to the screen. So the first repaint is, as you can see, providing coordinates for the old square, and the second repaint is providing coordinates for the new square. So what's happening here? What's happening is it is telling the display manager what are the damaged parts of the screen. What parts of the screen do we need to redraw? So if we have the rectangle here before, this is old, and let's say this is its new position, we really only need to redraw this portion of the screen and this portion of the screen. The rest of the screen is still up to date. So we call this an incremental redraw. Now, the display manager isn't quite as smart as we would like. It actually merges the two rectangles together. These are called bounding boxes because they bound the smallest area that was modified. So the two, when they're merged, we get a bounding box shown by the dotted red rectangle, which is the smallest rectangle that encloses those two changed bounding boxes. So what's going to happen is when we redraw, anything in this area right here is going to end up, including here and here, is going to end up getting redrawn. And repaint is what cues the paint event. If you forget repaint, your window will not get updated. I will cover this offset equals 1 in a moment. For the moment, just ignore the offset equals 1. So coming down now to our paint component method, you see that after drawString, we are drawing the rectangle, so that's what these 4 lines do. The first 2 lines sets the color to red and fills the rectangle. The second one sets the color to black and draws the border. So you'll notice there's a command fillRect that fills the rectangle, and drawRect draws the boundary of the rectangle. And if we go back and look at again our original thing, you can see there's a short or small black boundary around it, and when I move it around, the rectangle stays attached to the mouse. Now, there are a few pitfalls that you need to be aware of when you're dealing with these drawings. The first one is this super.paint component. You should always have super.paint component as your first call in paint component. So that's, if you remember, invoking the superclasses paint component method. And what that paint component method does is it actually redraws the damaged bounding box in the background color of the window, effectively erasing anything in that bounding box, and then allows you to redraw. The next thing that you need to know is that the order in which you draw objects is important. So in my application right here, I'm first filling the object and then I am drawing the border. So I'm actually going to say fill the object, and here I am drawing the border. Let's say that I do this in the opposite order, so that I first try to draw the border and then I'm going to draw the rectangle. This is because I'm only drawing with a single pixel wide boundary. It's not going to be really apparent what happens if I reverse the drawing order so that I draw the border first and the object second. However, if I was drawing with a bigger border, here's what would happen. So when I draw a border, it actually is centered halfway over the rectangle. So let's say this is a rectangle, it's 20 by 20. And let's say that I'm drawing a 10 pixel wide border. What happens is that 5 of the pixels are on the outside and the other 5 are on the inside. So that what gets drawn is a border like this that is 10 pixels wide and 5 pixels lying outside of the rectangle and 5 lying inside of it. So I actually end up with a 25 by 25 rectangle. And that makes the order in which I draw the border and the filled region important. If I draw the border first and then the filled region, I'm only going to end up with a 5 pixel border, because with my drawing the filled region second, it will cover up the inside of my border. So it's very important when we're drawing that we fill first and draw second, because if we draw first and fill second, we end up with this situation where the border is smaller than it should be. We can now explain why we need this offset in move square. Because of the way Java draws borders, slopping outside the actual rectangle, when we draw down here this rectangle right here using the draw command, it is actually drawing a 21 by 21 rectangle. And the reason is that because the length of the line or the width of the line is odd, that odd pixel is going outside of the rectangle. If we had drawn it 5 pixels, 3 pixels would go outside and 2 would go inside. So back here in our repaints, we have to make sure that we are adding half of the width of the line to what gets repainted. Let's show what happens if you forget this offset. So let's take these two, let's comment out these two repaint statements and instead repaint just using the dimensions that we provided to the draw or the draw rect command. So let's say square. And when we run this, you'll see that now I'm getting ghosting by 1 pixel. And this ghosting is all due to the fact that I didn't quite eliminate the old rectangle. So that's the importance of that offset bit right there. Okay, so the next thing that we need to talk about is something called drawing with sprites. So we'll call it Sprite Drawing. And in a real interface, we normally wouldn't just draw one instance of that rectangle. We might have thousands of instances. And so usually we create a class for each type of object in our GUI. So in this case, we'd probably create a rectangle class, and we put drawing code. So we place the drawing code for the object with the object. So that makes it very easy to see how the object gets drawn. So place the drawing code with the object. We'll show you how to do that in a moment. So we're now removing some of that drawing code from Paint component and placing it in a function in the object. The Paint component will call this method. So let's take a look at how we do that. So here we're creating a class called red square, and by default we're saying the x and y position to 50 and the width and height to 20. You can see we have set procedures for setting the x position, for getting the x position, setting and getting the y position, and for getting the width and height. We're assuming that the width and height are constant and hence can't be changed. And now down here you see we've created a method called paint square, which you're using to actually paint the object. So we've moved the set color, fill rect, set color, and draw rect down to this paint square method. And if we go back to paint component, you'll see that now we call red square dot paint. So we're still calling this method from inside paint component. Therefore, we're safe in terms of following our rule that we can only paint either within paint component or from methods we call from paint component. You'll see that we, at this top of as one of our instance variables, you can see that as one of our instance variables, we actually declared a red square variable and set it to be new red square. And now in our move square method, we are actually changing the red square. We're saying red square dot set x and red square dot set y. And you can see that we're still being careful to change our, or when we repaint, to add 1 to our offset. And here, the reason for these 4 variables, current x, current y, current w, and current h, is we don't want to have to make multiple calls to the methods getX, getY, because we're going to use current x, current y, current w, and current h in multiple places in our method. Hence, we get them right there, and we declare them final as hints to the Java compiler that these are constants, and if necessary, it can do optimizations with them. Now, if this were a real application with, say, hundreds of objects, we wouldn't just have one square, we would create instances of this square class multiple times, and inside of paint component we probably would have a loop that would go through and redraw all the red square objects. So we'd probably keep these red square objects, for example, in an array or a list, and then go through this list and repaint all of them. So finally, some last comments about painting. So some final notes. The first is that if you start looking at the Java documentation, you're going to get a bit confused. You'll see that there is something called a paint method. Something you should never ever call. That is what is called by the paint event method. Remember that repaint queues a paint event method. That goes on the event queue. Some point along with mouse events and keyboard events, this paint event gets dequeued and it calls a paint method. In turn, paint calls three methods. It calls your paint component method. Then it calls paint border, which paints the borders around your component. And finally, it calls paint children, because if you're a container object, it will paint whatever children objects. So if you have custom graphics in the same container as widgets, the widgets will appear on top of your custom graphics. And the final thing you have to be careful about, not so much in this course, but in later courses, is that if you're not careful to restore the graphics state to what it was when it entered paint component, this border could end up with funny colors. So remember that paint component gets called with a graphics object. And we went through and we did some changes to the graphics object, like we set the color to red. Well, if you're not careful and you leave the graphics object in the state red, then when the border gets drawn, it's possible that that border could get drawn red rather than, say, black. So typically what we do at the beginning of paint component is we actually create a new graphics object, say, call it copy G. And it uses, we call the create method. And that creates a clone of it. And then in our paint component method, we typically modify copy G. So we'd say copy G.setColor, say color.red. And we would use copy G to do our drawing. So for example, fill rect. And then at the end of our procedure, we would say copy G.dispose, which would tell the garbage collector that it's okay to garbage collect copy G. And this is very efficient because paint component gets called many times, but they've optimized this create dispose sequence so that you can essentially use a clone of the graphics component that gets passed in, change its state any way you want, not worry about the changes you've made, and then dispose of this copy at the end, and you leave the initial graphic state unchanged for your paint border and paint children. So let's just wrap up now with a summary of what we've talked about. So when you're going to do your own custom painting, you're going to start by creating a J-frame. Next, you're going to create your own JPanel. And you're going to override the paint component method, which is going to allow you to do some drawing. And you're going to override the get preferred size. Remember, if you forget to do it, then it will show up probably way too small. Remember, paint component gets a graphics object, which is going to allow you to do all of the drawing. And at the beginning of paint component, you want to make sure that the first thing you do is call super.paintComponent, and then you can do whatever drawing you want to do after that. Remember also that if you're going to create an object with a border, you need to fill first and draw second, because fill fills it, draw draws the border on top of it. So that's an important order. And then once you've done the paint component and get preferred size, you also have to add listener objects that are going to do event handling. So add listener objects to do event handling. And remember that these event handlers change application state and then call repaint. In fact, what they probably do is first call repaint. I'll put it right here. Call repaint with the old state info so that you can erase the old objects, and then you call repaint with the new state info, and that way you incrementally redraw your display. Remember, you do not paint directly from within your event handling objects. You allow paint component to do that, and the way paint component gets called is by you calling repaint. Repaint queues a paint event, and ultimately at the right time that paint event gets dequeued and paint component gets called. The reason you don't put your paint code in your event handlers is that you should only be painting when Java is ready for you to paint. And when it dequeues the paint event, it sets up that graphics object so that it is in a state that is consistent for painting. If you try to paint when you're not supposed to, like in the event handler, it's possible the graphics object is in an inconsistent state and you'll get anomalous behavior. That concludes this lecture on creating custom graphics.